cytometer is a device that is used for counting cells. It's a modified microscope slide containing two identical wells or chambers into which a small volume of cell suspension is pipetted. We have already removed 100 microliters of our cell suspension and placed it in a microcentrifuge tube. Dilute the suspension by adding 100 microliters of trypan blue. Trypan blue is a dye that helps us distinguish between living and dead cells. The dye passes through the membranes of dead cells, so they will appear blue under a microscope. Living cells exclude and will appear mostly clear. Load both chambers by pipetting the suspension under the cover slip. Now place the hemocytometer under the microscope. Each chamber is divided into a grid pattern consisting of 9 large squares. Each square has the same dimensions and contains 10 to the -4th power milliliters of suspension. The rules for counting cells sometimes differ from lab to lab. In our lab, we count cells in the 4 large corner squares and the center square. Let's count the cells in the first square. 1, 2, 3, 4, 5, 6, 7, 8. So what about the cells that are touching the outside boundaries of the square? In our lab, we count the cells that touch the top and left boundaries, and we ignore the cells that touch the right and bottom boundaries. 9, 10. We need to count the number of both living and dead cells. Remember, the dead cells will appear blue. Occasionally, you will see artifacts, objects or debris that appear blurry and don't have a well-defined shape. This is an example of an artifact. We won't include it in our count. Proper storage, cleaning, and handling of the hemocytometer will minimize the number of artifacts. There are 10 viable cells and 1 non-viable cell in the first square. Now, the top right square. There are 9 viable cells and no non-viable cells. Next, let's count the bottom right square. There are 11 viable cells and no non-viable cells. And now the bottom left square. There are 10 viable cells and 2 non-viable cells. And finally, let's count the cells in the center square. Sometimes cells will appear as clumps or small groups. It may be difficult to determine exactly how many cells are in a group. The method of counting clumps of cells differs from lab to lab, so be sure to follow the procedure in your lab. We will count this clump as 2 cells. There are 14 viable cells and no non-viable cells in the center square. The total number of viable or living cells from all 5 squares is 54. The total number of non-viable cells is 3. Now that we have counted our cells, there are several calculations we need to perform. First, let's calculate the percentage of viable cells. Here's the formula. 54 viable cells divided by 57, the total number of cells, gives us 0.947. Multiply by 100 and the percentage of viable cells is 94.7%. Next, let's determine the average number of cells per square. We counted 54 viable cells. We divide 54 by 5 because we counted in 5 squares. The average number of cells per square is 10.8 cells. Now let's calculate the dilution factor. The dilution equals the final volume divided by the volume of cells. Our final volume is 200 microliters because we started with 100 microliters of cells and added another 100 microliters of trypan blue. 200 divided by 100 is 2. Therefore, the dilution factor is 2. Next, we need to calculate the concentration of viable cells, the number of living cells per milliliter. Our average count per square is 10.8. The dilution factor is 2. 10.8 times 2 times 10 to the fourth power equals 216,000 cells per milliliter. We can write the concentration using scientific notation as 2.16 times 10 to the fifth power cells per milliliter. From our calculations, we now know the concentration of cells in our culture is 216,000 cells per milliliter, and approximately 94.7% are viable living cells.
Counting of the blood platelets using manual method or hemocytometer. The diluting fluid used for counting the blood platelets is ammonium oxalate 1%, or you can use a solution called Rice-Ecker solution. The first step is to dilute the blood sample 20 times using the diluting fluids. Here we will use a commercially prepared diluting fluid, raw 950 microliter from the diluting fluid. Put the diluting fluid in tube 950 microliter from the diluting fluid. The blood sample is mixed gently. Then 50 microliter from the whole blood is drawn using the micropipette. It is very essential to wipe the external surface of the micropipette to avoid pre-analytical errors. After that, mix the blood sample with the diluting fluid. Mix the blood sample with the diluting fluid. Take 8 microliter from the mixture from the diluted blood, and then apply to the hemocytometer slide. just in front of the cover, between the cover and the slide. Leave the fluid on the slide for about 15 minutes. And to ensure that there is no dryness of the fluid during the incubation period, it is better to put a wet tissue or wet cotton piece with the slide and cover them and leave them for 15 minutes. To ensure that there is no dryness, put a wet tissue or cotton piece and cover with the petri dish and leave them for 15 minutes. Put the slide on the microscope and examine under high power objectives. As we know, the hemocytometer slide is divided into 9 squares. So 9 squares appear under the microscope at 4x magnification. On 10x magnification, only 1 square from the 9 squares appear under the microscope. Here is the central largest square that consists from 25 squares. Every square from the 25 squares is divided into 16 squares. 16 squares. So the platelet is counted in these squares. We count the platelets under high power objectives in 4 squares in the periphery and 1 square at the center. So under high power objectives, when using the 40x magnification, the only 1 square from the 25 square appear, which used for counting of the platelets. As we said before, we count the platelets in 4 squares, in 5 squares from the 25 squares that present in the large central square. 4 of them on the periphery and 1 at the center of the large square. So in order to count the platelet, put the hemocytometer slide under the microscope and then start counting the platelets under high power objectives. As we said before, the platelets will be counted in the 5 squares from the central large area. The platelets appear under the microscope as small whitish particles, which is small when compared with the leukocytes present in the same slide. This is because the diluting fluid used for platelet counting destruct red blood cells and only white blood cells and platelets remain. So it is important to notice that the leukocytes present here may be mononuclear or may be replicated. Right? Leukocyte, and the small whitish particles is the platelets. This is the lower left square. So count all the platelets, which is the small particles, whitish particles appear here, and then after counting the platelets, move to the lower right square. This is the same, the lower right square containing white blood cells, large cell, and contain platelets. So count the platelets, the whitish small particles present here, and then after that, after counting the platelets, move to the upper right square, which is on the periphery of upper right square. Count also the platelets here, and then after counting the platelets, move to the upper left square. Move to the upper left square. After counting the platelets in the upper left square, move to square in the middle of the central area. The platelets is counted in 5 squares. After counting the platelets, calculate the number of platelets present per cubic millimeter. Platelets count per cubic millimeter will be equal to the sum of the number of the platelets in the 5 squares multiplied by 1000. So
Umumnya, jumlah trombosit normal dalam darah berkisar antara 150.000 hingga 450.000 trombosit per mikroliter darah. Langkah yang harus dilakukan mahasiswa untuk menghitung trombosit adalah membuat hapusan darah, kemudian mewarnai dengan cat light, baru dihitung trombositnya. Untuk melakukan pemeriksaan hitung jumlah trombosit secara tidak langsung, kita harus menyiapkan darahnya terlebih dahulu. Lakukan pengambilan darah vena pada bagian vena median kubiti. Ambil darah sebanyak 2 cc. Jangan lupa ditambahkan antikoagulan dengan perbandingan 1:1. darah siap, kita lakukan pembuatan hapusan darah. Hapusan darah yang baik akan terbentuk daerah tebal dan tipis dari kepala, badan, dan ekor. Tidak ada daerah yang berlubang-lubang ataupun terdapat robekan. Ini adalah hasil hapusan darah yang betul. Ada bagian yang tebal dan tipis. Yang di bagian sebelah kanan adalah hapusan yang salah karena terdapat penebalan di bagian tengah. Tunggu hingga benar-benar kering, kemudian siap untuk dicat. Selanjutnya kita siapkan cat right dan wafer untuk melakukan pewarnaan pada hapusan darah. Genangi hapusan darah dengan cat right sampai penuh selama 2 menit. Kemudian genangi dengan buffer, lalu ratakan dengan cara digoyang-goyangkan atau ditiup-tiup, kemudian tunggu selama 15 sampai 20 menit. Setelah 15 sampai 20 menit, buang cat, kemudian cuci dengan air mengalir sampai bersih. Bersihkan sisa air pada preparat, kemudian kering anginkan sampai benar-benar kering. Amati preparat di bawah mikroskop dengan lensa objektif 100 kali dan minyak imersi. Untuk menghitung trombosit, kita harus mencari zona ideal, di mana zona ideal ini akan nampak eritrosit yang berbentuk bulat terpisah dengan yang lain. Kemudian terdapat daerah gelap di bagian pinggir dan daerah pucat di bagian tengah. Ini adalah penampakan dari zona ideal hapusan di bawah mikroskop dengan perbesaran 1000 kali. Tanda panah orange menunjukkan sel trombosit. Hitung trombosit dalam 28 pandang, kemudian jumlahkan semuanya, lalu dikalikan dengan faktor pengkali, yaitu 1000. Misalnya, total trombosit yang diperoleh adalah 243. Jadi, jumlah trombosit dalam pasien per mikroliter darah adalah 243 dikali 1000, sehingga diperoleh hasil 243.000 sel trombosit per mikroliter darah. Hal ini berarti bahwa jumlah trombosit pasien masih dalam batas normal.